Hello everyone, I Neha Thakkar, Assistant Professor at New LJ Institute of Engineering and Technology. In last video lecture, we have seen the concept of hazing. Today also we will continue with that. In previous lecture, we have seen what is the concept of hazing, a simple example we have seen, and then also we have covered the what are the types of hash function. Today we are going to discuss types of hazing. Now, as I told you, it may be possible that if we are going to just apply a hash function and at the time for more than one key, we will be having what? A same index. So, the collision, how it is going to be that. Now, what are the solution for that? So, that all thing we are going to discuss in this video lecture. So, let's start with the types of hashing. Hashing is going to be divided mainly into two parts, that is a static and dynamic. So the name itself tells the static, that means it's going to be same. That means whatever the address or the we can say the location of index is going to be created, that is going to be not changed. But dynamic, that means what? It is may change, or you can just when the data is going to be deleted or the inserted, according to that it will just adjust. So that is nothing but what? A dynamic hashing. Let's start with a static hashing. In that one, what? The resultant data bucket address, that will always be the same. That means if you apply some hash function, so whatever the address is generated, that is going to be a same one. For example, we'll consider the hash table of size 10 as we have just taken in the previous video lecture. So this is a hash table. Now this values just we want to insert and we'll apply the hash function, that is modulo 10. Here in example, all the examples I'll just use a hash function, that is modulo 10 for the simplicity. So as we know, this 33, apply a modulo 10. So 33 will be stored here. Now 45 will be stored at this location. The next 56, so that is going to be stored at here, 56 at 6 location, 12 will be here, and 19 is going to be stored here as we have seen previously. Now what? The next key that I want to enter, that is what? 73. So if I'll do what? 73 modulo 10. So again you can see that I'll be having the answer what? 3. And you can see that this is here 3. So that 73 is also want to stored here. So this is what? The same index we will be having. And this is called a collision. That means we will be having a same index number for more than one key value. So what can be the solution of this? So for that, the solutions are two, the close hashing and open hashing. So this are, we can say, the two types of static hashings are there. Sometimes this is also known as a chaining, and open hashing can be known as a linear probing. So first we'll see what is close hashing. So the name itself tells you it's nothing but what? A chaining. So chaining, that means what? Suppose this is already inserted. Now more keys that I want to insert, that is first one is 73. So what I'll do, 73 modulo 10, so I'll be having 3. So it's a chaining, that means it is go to this location only at 3, because stating means what? The whatever the address is going to be generated or index, that is not going to be changed. But what happened, this 73 is going to be chained with 33 on the same index. So here what happened? The chaining is going to be created. The next is suppose 59. So for 59 modulo 10, what happened? Will be having the 9. But some data is already stored at that location. So again a chaining will be there. So it is kind of what? A linked list is going to be generated at particular index 9, 19, 59. If you find some another value, then again it's going to be a chain. 53 next. So you can see that 53 modulo 10. Again you will be having the 3. So same location, same index, add there. Again the chain is going to be added. And here it will store what? 53. So in this way, it is called what? The chaining. It is one of the solution of collision. Now what happened in that? Again, you can see the same, we can say the disadvantage or the limitation is here if we know that the database is going to be a larger one, right? So there are so many values can be possible, keys can be possible, they'll be having the same index. So if any searching you want to do, so for example, it will be fall in this one, third index. And again, third index, there will be a list of chain or a list of values are there. So again, we have to go for all the value. For example, if you want to search a 53, then you have to start from 33, then again 73 like that. So we'll be having the another solution, that is open hasing. Open hasing, what happened in that? Suppose this is some values already there in a hash table. Now the same example as we have taken previously in a chaining, that I'll be taking. The next key values we want to insert, that is 73, 59 and 53. So 73, the same hash function will take, that is 73 modulo 10. So we will be having 3. So now what happened? It is not going to be stored at the third index, but it will search a next free location and the key value is going to be stored at that. So for example, the next free location after that third index will be 4. So the 73 is going to be stored at this location. The next is 59. So at the 9th location. So you can see that this is already full. So what happened? It will just go up and this is 0 is a free. So 59 is going to be stored at that location. Again the 53. So the index is 3. So this is not available. So again it will search for the next free location. So it will be available at 7 index. So the 53 is going to be stored that. So this is called what? The linear probing. Now what happens? Sometimes it may happen that actually the hash table size is going to be a larger one. Here just for simplicity we have taken the size of 10. Now what happened in that? Sometimes may happen that your hash table is going to be a full, and if you want to still enter some value or if you want to insert some values keys into the table, then what happen? So you can take a hash table size of more than 10 and you can do the rehashing. So in this way the static hashing is going to be work. The collision may occur. So we have also seen the solution for that, that is linear probing and chaining. Now we will see the concept of dynamic hashing. So this is the method is used to overcome the problem of what? The static hashing, that is bucket overflow. As we have seen that if you are going to use a linear probing, that what happened? Sometimes it may happen that some of the values or a key you want to insert, but the no space is there in a hash table. As it's a static one, so the size of the hash table is a fixed one. Now data buckets can be grow or it can be shrink as the records are increase or decrease. So in dynamic hashing you will be having the facility, that means what? Sometimes it may require that if you want to just having the more key values and there is no space in a hash table, so your data bucket size is going to be grow. Sometimes that some records are going to be deleted, so at that time you can also shrink it. So this is what? A dynamic runtime. You can change the we can say the size of what? Hash table. That means you can add a data bucket or you can just remove the data bucket. This method is also known as a extendable hashing method. So we'll see the example of dynamic hashing. Consider the following group of keys. That means some keys are given from 1 to 7 and it will be having what? The hash address. That is and depending on the prefix of their hash address. So what happens, just we are going to create a pointer or the data records, how it's going to be stored and what can be the data bucket for each one. So now we can see that whatever the hash address is given, the last two digits are what? A 1000. The another possibility is 01 and the third one is what? 11. So we'll be having this four possibility. So just we create a four size here. After that, what happened? How it will be stored in a particular data bucket. So here we have taken the four data buckets. Now you can see that this 2 key and the another one is a 4. This both will be having a last two digit, that is 0, 0. So what happened in the 0, 0? This is point to the bucket that is having two value, that is 2 and 4. Same way the next, that is what? 5. The last two are 0, 1 and we can say the 6 is having last two 0, 1. So this 5 and 6 both data, they are going to be stored in the bucket B1. Same way the another is having 1, 3 and the fourth one, that is 7, is going to be stored in a B3. Now what happens? Suppose some another key that we want to insert, that is 9. It's having the address, has address, that is 1000001. Now you can see that the last two digits are 0, 1. So it is this bucket 0, 1. That means here the entry should be that, the 9, right? But what happened? It is full. This is a full. So what happened? How it is going to be stored? Because the last two digits are 0, 1. That means what happened? We need to create another bucket. So again the another bucket is going to be created. And also this arrangement, that means the values are also going to be readjusted. How it is going to be done? For example, here you can consider last three digits. Last three digits are what? 0, 0, 1. Now we'll be having at this bucket 5 and 6. So just we'll see what is the value or last three digit of 5 and 6. So for 5 it is what? 0, 0, 1. That is same as the 9. And the 6 is having what? A 1, 0, 1. Last three digit. So what happened? The 5 and 9 will be having the last three digits same. So it will follow, or it will just going to be stored into the same bucket. You can see that like this. Now here the data records. You can see we have considered last three digits. So the total we can say the 8 are going to be created, and for each and everything 2 and 4, you can see that 2 and 4, so last three digits are same, so it will be stored in a same bucket 0. 1, 3 is having same, so they are going to be stored at the same. 7 is also. Now 6 is going to be separated because 5 and 9 is going to be stored in a bucket B1. Now extra bucket is going to be added, that is suppose a B5. So here the last three digits are 101. Can see that. So at that the pointer will be there in a data bucket and 6 is going to be stored here. So in this way, in dynamic hashing, the sometimes you will feel like or the space is not available for particular key. So you can just add a data bucket and also the rearrangement can be done. So it's not like that whatever the new bucket is there, in that you have insert 9 or you want to insert 9, so that is going to be stored here 9 directly. No, the readjustment of whatever the data is going to be there, that is also be there. So obviously it will take a more time as compared to static hashing, but whatever the problem of static hashing is that means bucket overflow and all, so that is not going to be here. So these are the two types of static hashing and dynamic hashing. Thank you for watching this video.